First of all, I welcome all the students and the participants who are attending this live lecture. See this, today in this live lecture we shall discuss the Lagrange's equation of a motion for Atwood machine. See this. Also you know that yesterday we have seen the Lagrange's equation of a motion. Okay. But we have to use the Lagrange's equation of motion, or by using the Lagrange's equation of a motion, we have to find out Atwood machine, equation of a motion of the Atwood machine. You know what is meant by Atwood? Nade, Pooja Atolkar, Saurabh Wade, Prajakta, Pratiksha Chavan, Mayuri Gore, Kiran, Sarika Deshmukh. Do you know what is meant by Atwood machine? Actually, we have to find out the equation of a motion for the Atwood machine. This is the particular type of a machine and its work is particular type of work. So you know what is meant by which type of a machine that is particularly called as a Atwood machine. See this, actually we have to find out the different forms of Lagrange's equation. We are solving the problems based on the Lagrange's equation of a motion. Actually we are solving the problems based on Lagrange's equation of a motion. Yesterday we have seen how to calculate the equation of a motion of a pendulum. So today we shall discuss how to find out the equation of a motion of Atwood machine. So you first of all you must know what is mean by Atwood machine. Atwood machine के बारे में आप कुछ जानते हो क्या students? Are you know what is mean by Atwood machine? So this is the Lagrange's equation of a motion. This is the Lagrange's equation of a motion. So we can write this Lagrange's equation of a motion is this. This is the Lagrange's equation of a motion in terms of kinetic energy, okay, and potential energy. The equation of a motion in terms of a kinetic energy and potential energy. So actually this is the equation of a kinetic energy and potential energy. Pi इथं माझ्या मतानुसार QJ आहे, QJ, see there. This is the equation of a motion in the form of QJ. I shall write this. QJ means the generalized force. QJ means the generalized force. Okay. बराबर है का बघा रे students? What is mean by QJ? QJ means the generalized force. So the Lagrange's equation of a motion is d by dt. See this. You know that up till we have studied the theorem based on this Lagrange's equation of a motion. See this, I shall revise this again part. Generalized coordinate is given by this relation. Generalized velocity is given by dr by dt, which is equals to v bar summation over this. This is a virtual work done. Virtual work done is given by fi bar dot dri bar. You know that the principle of the virtual work done means summation over I is equals to 1 to n fi bar dot dri bar is equals to 0. Also we know that the D'Alembert's principle. D'Alembert's principle. What is that D'Alembert's principles here? D'Alembert's principle is given by, for a displacement of the system we have summation over I is equals to 1 to n fi minus pi bar dot into delta ri, which is equals to 0. Also d by dt of, this is the Lagrange's equation of a motion in first kind. Lagrange's equation of a motion in first kind, d by dt of dou t divided by dou qj, which is equals to dou t divided by dou qj, which is equals to qj, which is equals to qj, where t is equals to kinetic energy summation over 1 by 2 mi into vi square. QJ, तिथं QJ विसरला होता, ठीक आहे. And this is the second Lagrange's equation of a motion in second kind, which is in the form of a Laplacian d by dt of dou L divided by dou Qj dot, which is equals to dl upon dou L upon dou Qj, dou L upon dou Qj. ओके, अशा पद्धतीने हे लॅग्रांजेज इक्वेशन ऑफ अ मोशन होतं. ठीक आहे. आता आपल्याला नेक्स्ट वी हॅव टू सॉल्व द प्रॉब्लेम्स. क्वेश्चन, Lagrange's equation of motion for Atwood machine. We have to discuss this question. What is that question here? Explain the Atwood machine and find its equation of a motion. Explain Atwood machine and find its equation of motion. Do you know what is meant by Atwood machine? See this, the concept of Atwood machine is which is used in the lift. You know, lift which is used to traveling upward and downward direction. You know, lift. The principle of lift is totally based on the Atwood machine. See this, suppose the concept of Atwood machine is, I shall draw this. Suppose this is a pulley, this is a pulley which is extended, connected by the string to the rigid support. Now two masses, suppose this is a mass M1 and this is a mass M2, which are attached to the pulley. We shall draw this thoda. These are the two masses which are attached to the pulley. Suppose that the radius of this pulley is, small a. This total length is the string of the length which is attached to the pulley. This is a circle. Circle means actually this is a pulley. Wheel. चरखा. याला चरखा म्हणतात. पुली म्हणजेच चरखा. This is a pulley. Pulley of the radius A. Means see this. Suppose this is a pulley which is attached to the fixed point and two masses M1 and M2 are, suppose this is a mass M1, this is a mass M2, which are attached to the pulley. Now the strings, this length of the string which is attached to the pulley is suppose this is a x2. Diagram व्यवस्थित नंतर काढा. And this is a x1. Length of mass towards M1, length of the string towards the M1 is given by length. This side length is given by, see this side length is given by, here this length is given by x1, this length is given by x2. x2 means the length of a mass M2 which is suspended by the string of length x2. The mass M1 is suspended by a string with length x1, but both are the string are connected on one another by using the pulley. So we can move M1 and M2 two particles or two masses upward and upward direction and in downward direction by using the pulley. See this. So see this pulley is attached to the, see this pulley is attached to the some fixed point. So this work is known as, see this, working of this pulley is used, or it is also called as Atwood machine. So working of this Atwood machine is used. 1 minute. See this working of this Atwood machine is used in the lift. ये देखो ये मशीन का बहुत जगह पे यूज होता है, कहाँ पर भी ये मशीन यूज कर सकती है. We have to use this machine everywhere which we have to lift some mass, large amount of a mass which we want to lift, then we have to use the working of this Atwood machine. Okay. समझला का रे? This is the concept of Atwood machine. This is the concept of Atwood machine. परत एकदा पहा, suppose consider two masses M1 and M2 are connected by a string of length L, small l, which is taken over the pulley. So pulley is attached to the fixed point O and which is movable on the string, an extensible string. So length of a mass, suppose at any instant the length of the mass from the pulley M1 from the pulley is x1, length of the mass M2 from the pulley is x2. So the total length of a string which is given by one minute. See this, okay? Now we shall discuss this concept of a pulley. Now we shall write. आता ही concept आपण लिहून घेऊ. Concept लक्षात ठेवा. I shall explain this. Now we have to find out the equation of a motion of a pulley. Now see this. Okay. The working of Atwood machine is a holonomic. See this is a holonomic and scleronomic constants. Holonomic and scleronomic constant with 1 degree of freedom, with degree of freedom is 1. Okay. Atwood machine is a system. See this. Atwood machine is a system which consists of two masses M1 and M2 suspended over a frictionless pulley. frictionless pulley. Okay. See this. Of a radius, the radius of a pulley is suppose A. Let A be the radius of a pulley connected by the flexible string of length L. Here capital L. See this length, see this length is capital L and this length is a small l, length of total rope. Here L is the length of a rope. Here small l is the length of rope for which the masses or particle M1 and M2 are attached. M1 and M2 are attached. See this. Here in this system, there is only one generalized coordinate generalized coordinate say x1 because see this, there is only generalized coordinate say x1 because the second side, that is x2, can be calculated from x1 because x2 can be calculated by using x1 such that, see this, actually there is only one generalized coordinate x1. You observe that there are actually two coordinates x1 and x2 which are continuously going on, increasing, decreasing, means changes. You note that x1 and x2 are continuously changes, but x2 can be calculated by using the value of x1. How to calculate x2? Now you tell me, students, how to calculate x2? सांगा रे students, x2 कसा calculate करता येईल? How to calculate x2? Who can tell me? See this. This is a x1. This length is x1. This length is x2. This length is x2. This length is x1. And this is a half perimeter. This is the half perimeter. Then we can find the total length L. Length of rope. How to calculate the length of rope? How to calculate? सर्वांनी आन्सर द्यायचं रे, मी स्क्रीनशॉट घेतोय प्रत्येकाचा. How to calculate the total length L? Total length L is in three different parts. First part is at x1, second part is x2, and third part is half perimeter of a pulley. Half perimeter of a pulley. So we can write that half perimeter of a pulley means pi a. So we can such that L is equals to such that x1 plus x2 plus total perimeter of a pulley is, what is the formula for perimeter? Students, now you will tell me what is the formula for perimeter of a pulley. The radius of a pulley is suppose small a, then perimeter is total circumference. Perimeter म्हणण्याच्या ऐवजी आता तुम्ही circumference म्हणा. Circumference, use the formula for the circumference, that is circumference means 2 pi r. That means perimeter of the pulley is 2 pi r. Half a perimeter which is used here. यहाँ पे देखो कितना यूज हुआ है, यहाँ पे आप देखना है हाफ पेरीमीटर वी हैव यूज्ड हियर. half perimeter which we have used here. See this is a x1, this is a x2, and half perimeter which is given by, half perimeter means pi a, 2 pi r. Very good. Anita Rajmane, Prajakta Kadam, the perimeter, formula of the perimeter is 2 pi r. So we can write this size. So we can write this as x1 plus x2 plus pi a into pi, which is equals to 0, sorry, which is equals to L. So we can write x1 is equals to L minus x2 minus pi a, or a into pi. Thus we can find the value of x2. So we can definitely say that there is only one generalized coordinate, and that coordinate is given by x1. So now we know that the kinetic energy of this, see this, now continuously two masses are moving. You know, in the lift continuously one side is the part of lift and other side of that lift. I know you might have seen the lift which is used to climb the building floor to floor. That lift you have seen. One side is M1 means one part of lift is given by cabin, and M2 means other part of that mass which is equivalently given masses there, M2, by the rods. There are big rods which are given equivalent masses to the M1. Okay, you have to see this part. Now we know this can be written as this. Now equation of the motion, kinetic energy of the, so we have the kinetic energy is T is equals to 1 by 2 capital M into V square. Capital M means addition of both masses, that is 1 by 2 small m1 plus m2 into V square, velocity, that is x dot square. V square means that is a x dot square or x1 dot square. We can write this as a x1 dot square, because x2 can be measured in terms of x1. Suppose this is the equation, this is the equation 1. We shall write this equation 1. We shall write this equation suppose 2. Also the potential energy also, the potential energy is given by V is equals to, what is the formula for the potential energy? The formula for the potential energy is mgh. But here the height, that is the pulley is working in the opposite direction of gravitational force. So we have to take here g is negative. So we can write m minus capital M g into x1, that is a minus. Minus means you know that the masses are lift upward direction, downward direction, that means it works in the opposite direction of a gravitational force of direction, because gravitational force of attraction is in downward direction, lift is going upward direction, that means it works as a opposite direction. So capital M means we can give one m1 plus m2 into z into x1. This is not I. x1. Now separate this, therefore the potential energy V is equals to minus m1g into x1 minus m2g into x2. Suppose this is the equation number 3, which is used for the potential energy. But here x2 can be, okay, x1 and x2, mgx. We shall write mgx, x means mgx. Here we have to use mg into L, samjha h. H means actually we can use this minus m1 plus m2 in, we can write this m1 mass into g into h. H means x1 minus m2 into g into x2. Mass 2 ची height x2 आहे पहा. See this. m2 having the height x2. So we can write this as m1g x1, m2g x2, but x2 means we can write as V is equals to minus m1g x1 minus m2g into x2 means what? We can write x2. x2 म्हणजे किती आहे पहा? L minus x. We can write x2. How to write x2? We can calculate this x2. इथं घेऊ आपण. x2 can be calculated. So x2 which is given by x1. No problem. So x2 can be given by, how we can write? That is L minus x1 minus a into pi. So V is equals to minus mg x1 minus m2g L minus m2g x1 minus, that is equals to m2g into a pi, and this minus minus will be plus, this minus minus will be plus. m2g, m1. So this is a m1, this is a m2. Okay. So we get minus m1g x1 minus m2g into L. So x2 can be written in this way. Suppose this is equation number 2. Now we know that to find the derivative equation of Lagrange's equation of motion, we know that the Lagrange's equation of a motion is Lagrange's equation of a motion is d by dt of dou L divided by dou t, dou L divided by dou x1 dot, generalized coordinate is x1 dot minus dou L divided by dou x1, which is equals to 0. Suppose we can write this as a 3. Okay, where L is equals to t minus v. Now we have to calculate dou L by dou x1, that means dou L by dou t by dou x1, dou t by dou x1 dot. So we can write this as, now L is equals to t. T means what? Put the value of t. T means 1 by 2 m1 plus m2 x1 dot square minus, we can write V. V means we can write this, that is M1 gx1 minus M2 gl plus M2 gx1 plus M2 g into a pi. So put this value. So we can write this as, so we get L is equals to 1 by 2 into M1 plus M2 into x dot square minus, now we will get the relation minus M1g minus this, then minus minus plus, what is that relation? बघा बरं रे, बरोबर आहे का? M2gx1 बरोबर आहे ना स्टुडंट्स? M1gx1 M1gx1 okay, then minus M2gl which is equals to minus plus. तुम्ही चेक करा रे, रॉंग झालं का काही पहा. M1gx1, what is that? Minus minus plus, this will be get cancelled, so minus minus plus, this will be plus. Okay, okay, no problem. 3 टर्म येतील, 3 टर्म. इथं 4 कशा आल्यात रे? एक मिनिट, वी हॅव टू राईट दिस टर्म अगेन. मी इथं खाली लिहितो मायनस, आय शॅल राईट हिअर M2gl this is a minus M2gl, then this is a plus M2g into x1, and this is a plus M2g into a pi. हाँ बघा रे, बरोबर आहे का? चेक करा एकदा. These are the 3 terms we have to replace. Actually 4 terms we have to replace here. This is a V, that is a minus M1gx1 minus M1gx1 plus, this is also minus. So we can write this as M1gx1 पुन्हा M2gl plus M2gl, then third is minus M2gx1, and then fourth is M2g a pi. M2g a pi. 3 टर्म येतील ना का 4 टर्म येतील? ओके, समजतं का हे? आता ठीक आहे. नाउ वी हॅव टू कॅल्क्युलेट dou L by dou x dot x1 dot, means we have to take derivative of this term with respect to x1 dot. So we can write this derivative with respect to x1 dot means 1 by 2 into m1 plus m2 into 2x1 dot plus derivative of total remaining term with respect to x1 dot is 0. So this 2 will get cancelled. Therefore dou L by dou x1 dot, which is given by m1 plus m2 into x1 dot, m1 plus m2 into x1 dot. ओके, हे बाकीच्या टर्म मध्ये x1 डॉट कुठंच नसल्यामुळे 0. सो वी हॅव टू राईट दिस इक्वेशन. सपोज 4, याला आपण 4 देऊ. ऑल्सो dou L divided by dou x1. Also we have to take dou L divided by dou x1. How we can write dou L divided by dou x1? Means this is a x1 term, the first term derivative, this total term is 0. Now derivative of this x1 is plus m1g plus m1g. This goes to 0. Derivative of second term is 0, first term 0, second term is m1g, x1 चा डेरिव्हेटिव्ह 1 येतो, minus m2g x1, so m2, this goes to 0, m2gl चा डेरिव्हेटिव्ह 0, minus m2g into x1 चा डेरिव्हेटिव्ह 1, minus 0. So we get dou L by dou x1 which is equals to m1 into z minus m2 into z, which is given by m1 minus m2 into z. Suppose this is equation number 5, this is equation number 6. Now put this 5 and 6 in equation 3. Put equation 5 and 6 in equation 3. So what is that 3? Dou L by dou x dot x1 dot d by dt of dou L by dou x1 dot minus dou L by dou x1 which is equals to 0. So we can write d by dt of dou L by dou x1 dot means m1 plus m2 into x1 dot minus m1 minus m2 into z. Dou L by dou x1 means m1 minus m2 into z, which is equals to 0. Now differentiating this with respect to again t, x1 dot चा डेरिव्हेटिव्ह परत एकदा काढा. So we get m1 plus m2, these are the constant quantities, put it as it is. Derivative of x1 dot is x1 double dot minus m1 minus m2 into z, which is equals to 0. Now dividing by m1 plus m2 on both sides. So x1 dot minus m1 minus m2 divided by m1 plus m2 into z, which is equals to 0. This is the required equation of this is the required equation of motion of Atwood machine. समजलं का रे? हे समजलं का सर्व तुम्हाला? दिस इज द रिक्वायर्ड इक्वेशन ऑफ अ मोशन ऑफ Atwood मशीन सिरीज. हे दिस इज द रिक्वायर्ड इक्वेशन ऑफ Atwood मशीन. म्हणजे खूप इंटरेस्टिंग आहे ॲक्च्युअली. तुम्हाला माहीत राहावं हे जे इक्वेशन ऑफ अ मोशन ऑफ Atwood मशीन म्हणजेच ॲक्च्युअली जी लिफ्ट आहे पा, लिफ्ट. आपण जेव्हा लिफ्टमध्ये वर इमारतीवर जातो, इमारतीतनं खाली येतो, त्या लिफ्टच्या इक्वेशनचं मोशन हे आहे. Equation of the motion of the lift is this. M1 means the part at which we stand. In that lift, M1 means the part at which we stand, and M2 means the parallel mass attached other side of that lift, that is M2. So this is the equation of the motion of lift. Atwood machine means one type of a lift. Working of a lift is a totally based on the Atwood machine. Okay, समजलं का? हे एक एक कन्सेप्ट खूप महत्त्वाचे आहेत. एक एक कन्सेप्ट तुम्हाला 15 मार्क्सला विचारतात पा. दिस इज अ व्हेरी इम्पॉर्टंट फॉर 15 मार्क्स. व्हेरी इम्पॉर्टंट फॉर 15 मार्क्स. चला, कुणाला जरी शंका असेल तर विचारा. इफ यू हॅव एनी डाऊट इन दॅट वर्किंग प्रोसेस, इफ यू हॅव एनी डाऊट in that working process, you can ask. Here from equation 1 we can find x2 or x1. We can find x2 or x1. So you can write here, you can write from 1. इथं वाटलं तर लिहा from 1. फ्रॉम 1 वी कैन पुट द वैल्यू ऑफ x2. ये देखो, ये x2 ची वैल्यू आपण पुटअप करू. फ्रॉम इक्वेशन 1 वी कैन पुट द वैल्यू x2, देन मल्टिप्लाय. दिस इज द टोटल पोटेन्शियल एनर्जी. आणि हे मायनस कशामुळे आलं लक्षात आलं का रे? ॲक्च्युअली दिस मायनस मीन्स द लिफ्ट इज वर्किंग. Actually the lift is working opposite direction of the gravitational force, because the gravitational force is in downward direction. Generally working procedure of lift is in upward direction, so it is considered as a minus. पुन्हा नंतर कॅल्क्युलेट केल्यानंतर विल गेट, इकडे प्लस आला पाहिजे, एक मायनस येतो एक प्लस येतो. म्हणजे m1, सी दिस in the potential energy, see this V is equals to m1gx1. m1gx1 means mass 1. जर वरच्या दिशेत जात असेल तर मायनस येतं, तेव्हा x2 पॅरलली खालच्या दिशेमध्ये येत असतं. ठीक आहे, त्यामुळे सेकंड जी टर्म तिथं पॉझिटिव्ह आली आहे. ओके, नो प्रॉब्लेम. काय अडचण आहे का रे? साईनाथ सेवरे तुझं इथं कुठं आहे रे? नाडे मोहिनी, नवीद खान, सौरभ वाडे काय आहे का अडचण? आज उदगीरकर नाही आला का रे? रुपाली कुमटेकर, सर्व मुलाचे नावं माझ्याकडे नोंद आहेत पाक. जे जे क्लास करत नाहीत त्यांचे नावं मला माहीत आहेत. ओम पण आला नाही आज. ओम मी लक्षात ठेवतो, पुन्हा तुम्हाला हॉल तिकीटच नाही देत बघा ना. एक वर्ष तुम्हाला असं बसवतो घरी. ओके, नाउ यू हॅव एनी डॉट. So you have not any doubt, then I shall stop here. परत एकदा चेक करा. I shall revise this. Atwood machine means I is like the lift. Two masses are connected by using the rope, that is small l. The pulley is attached by another rope with fixed attachment, that is the length of that is L, capital L. See this is a capital L. This is capital L. Suppose the radius of a pulley is considered as a, then x1 and x2. x1 means the distance of m1 from the center of a pulley. x2 means the distance of second mass from the center of a pulley. So the total length is given by x1 plus x2 and the semi perimeter or semicircle, circumference of the circle. So we can write that is x1 plus x2 plus a into pi is equals to L. So we can obtain the x2. Okay, now we can write this. Okay, हा थोडा कॉम्प्लिकेटेड टर्म आहे. पोटेन्शियल एनर्जी मध्ये थोडी कॉम्प्लिकेटेड टर्म आहे. लक्षात ठेवा, फक्त x1 आणि x2 व्हेरिएबल आहेत, बिकॉज दे आर कंटिन्युअसली चेंजिंग. So we consider only the generalized coordinate is x1, because x2 is also depend on x1. x1 and x2 are two variables, but we have considered generalized coordinate is x1 because x2 is also another variable term, but value of x2 is totally depend on x1. So there is only one generalized coordinate. See, this is a very important. So we can write this V is equals to in this way. This is the potential energy, this is the kinetic energy. So according to the Lagrange's equation of a motion, according to the Lagrange's equation of motion, Lagrange's equation of motion, d by dt of dou L by dou x1 dot minus dou L by dou x1. So L means T minus V. Put the value of T means kinetic energy, V means the potential energy. From kinetic energy is considered as, अरे इक्वेशन चुकले वाटतं मला, हे 2 आहे, इक्वेशन चेक करा थोडं, हे 3 आहे, जाऊ द्या काय हरकत नाही आहे. सो वी कॅन राईट, याची गरज पण नाही, असू द्या. ओके, यू कॅन राईट धिस टू, नो प्रॉब्लेम. थोडं लक्ष ठेवत चला रे स्टुडंट्स. मी सांगत असताना, मी समजून सांगत असताना माझं लक्ष तुमच्याकडे असतं, म्हणून बऱ्याच वेळा मायनस प्लसमध्ये रायटिंगमध्ये बऱ्याच वेळा मिस्टेक होत असतात. स्क्रीन छोटी असते, दिसत नाही, स्क्रीन पाहून लिहावं लागतं, त्यामुळे मिस्टेक होत असतात. तुम्ही सांगत चला वेळेवर. ओके, नाऊ वी शॅल स्टॉप हिअर.